Okay, Assalamualaikum warahmatullahi wabarakatuh. Today's lecture will be on the hardened concrete. This lecture will be presenting by Haslin Idayu Amaruddin. On the previous topic, we have learned about the properties of fresh concrete. So right now we are going to look into the properties of hardened concrete. Alright, so learning outcomes, at the end you should be able to identify the properties of hardened concrete, and then you need to explain the factor affecting concrete strength and understand the concretity in different environment. And also you have to identify the durability of the concrete and also the testing of hardened concrete. Alright. Okay. The figure 1 shows the description of setting and hardening of cement paste. We have three stages here. The first stage is within what we call as initial setting time, within the 45 minutes of addition of water and mixing the cement and water. And this condition is the paste is plastic and workable paste. At the end of this stage is what we call as initial set. And the next stage is the setting time, where the paste is become stiff and unworkable. At the end of this stage is what we call as final set. Final setting time is basically maximum about 10 hours after mixing. Once the next stage is on the hardening. After the final set, the paste is become more rigid and gains its strength with time. Okay, so these are some description of the setting and hardening of cement paste. The first is dormant period, which is the time from mixing of cement with water to produce plastic workable paste. So basically this is the paste remain unchanged for 2 to 4 hours. Okay, so the next stage is on the setting, which is the paste is become stiff and also unworkable paste. And the last stage is the hardening process. The process with time, harden the paste continues to harden and gain the strength. In setting and hardening, we also have initial set, which is the paste begin to stiffen to such a degree it becomes unworkable. The final set is the paste continues to stiffen until the stage is reached. So it may be regarded by a rigid solid, it becomes solid. So initial setting time is the time required for the paste to reach the initial set, and final setting time is the time required for the paste to reach the final set. Okay, so properties of hardened concrete. So the first properties that we are looking to is the strength of the concrete. And then we look into the deformation under load, the durability of the concrete, the permeability of the concrete, and also the shrinkage of concrete. Okay, we are going to look into these properties one by one. So the first one is the strength. The strength is the most important properties of hardened concrete. The strength is actually defined as the maximum stress it can resist or the maximum load it can carry. To test for the strength, normally we use specimen in terms of cubes, cylinders or prisms, and we test due to compression requirement. And also we test the strength in terms of flexural tensile test. In this test, we estimate the load which the concrete can carry before it cracks. Means when we apply load, it deforms and we check the cracking. And also we check for compressive strength, which is we taken the maximum compressive load the concrete can carry within unit area. Okay, strength of concrete is basically increased with age. So basically within 28 days, supposedly we can reach our 100% strength requirement if we cure the concrete. So the first curve on the top one is when the concrete is more secure entire time. So the process of concrete reach is 100% strength is higher as compared to when you are not cure your concrete cube. So you are not going to get your 100% strength. So that is why curing is one of important stage of hardened concrete. Okay, so what are the factors influencing concrete strength? Mainly the factor is due to constituents material, which is we have water, cement, aggregate and admixture. It will affect the strength of the concrete, and also the method of preparation, where we prepare the concrete from batching, mixing, placing, and also the compaction of the concrete, and also the curing process, which how much water that we put, the temperature, and also the time for the curing, and also the test condition, the specimen that we use for testing also influence the strength of the concrete that we get. Okay, so let's look into the factor one by one. So the first one is the factor influenced by the constituent material. The first one is the cement. The finest the cement that we use will increase the strength, and also the chemical composition of the cement will also affect the strength of the concrete. So we have to choose our type of cement properly so that we can get the required strength. Okay, so the next is material water. Water cement ratio required for hydration process of the cement. So that's why enough water amount should be put in our concrete mix, so that in the end it will affect the strength. And also the aggregate. The bond strength between aggregate influenced by the surface texture, shape, and also the cleanness of the aggregate. The compressive strength of concrete tends to increase with the decreases size of coarse aggregate. This is due to the smaller size of the aggregate provide larger surface for bonding with cement mortar. Okay, so that's why the compressive strength will be increases. And also if the aggregate is roughness, it also considered as bond strength, higher bond strength, that lead to the improvement in mechanical interlocking, so that it will improve our strength. And the third material is, and the last material is admixture. If we add some admixture in our concrete mix, it may increase our strength. So it depends on the precise nature of the admixture itself, the function of the admixture. Okay, the second factor that we are going to look is the degree of compaction. Proper compaction will increase the strength, since when we compact, we remove some void in the concrete, so the concrete become low in porosity, so that it will result in higher strength. The increases in the strength of the concrete probably influenced by the volume of void in concrete. For example, we have entrapped air, capillary pore, gel pores, or drain, so that's why we need to improve the porosity of the concrete. Okay. And then the influence of curing. Curing of concrete is prerequisite for the hydration of the cement contact. So the longer the period of curing, the greater its final stage. In curing, we have early stage and later stage. Basically, if we cure about 7 days, it may enough for us to get the 100% strength, or we can cure for 28 days for better concrete strength. Okay, so the fourth factor that affecting our strength is the test condition, which is much more depending on the specimen or the size of the testing specimen, and also the specimen moisture content and temperature during the testing, and also method of we are load the testing specimen. Okay. So the last one is the deformation under load. Concrete will deform under load. Deformation increases with the applied load. So it means that it is what we call as elastic deformation. So under normal loading, when the first effect of applying a load to concrete is to produce elastic deformation. As the load increases, deformation will also increase. It means it linear. When we increase the load, then the deformation will be increased. In elastic deformation, when the applied load is released, the concrete does not fully recover its original shape. So in some concrete, the concrete does not recover its original shape. It has a small amount of deformation. So under repeated loading and unloading, the deformation may be increased. Okay, so here for example, for the initial state, we do not put any loading. Okay, and then after and then we put 100 kilonewton. After a day, we see some deformation. This is what we call as elastic deformation. And the loading, if we leave it for 10 years, for example, for a longer time, then the deformation will be more. Okay, so from the deformation, elastic deformation, we can get our properties of the concrete. The first properties that we can get is the elasticity of the concrete. The modulus of elasticity, the E value, is defined as the ratio of the load per unit area, which is the stress to elastic deformation of the unit length. Okay, so basically the E value is the stress divided by the strain. For common values for concrete for 28 days, the range is in between the 15 or to 40 kilonewton per millimeter squared. So another properties that we can get is the Poisson ratio, which is defined as the ratio of the lateral strain to the associated axial strains. Poisson ratio can vary from 0.1 to 0.3 for normal working stress. Okay, alright, so that one is for the strength of the concrete. So now we look into the other properties of the hardened concrete, which is the durability of the concrete. Durability is defined as resistance against deterioration or failure process that may occur as a result of interaction with the environment or external factor between the material and also the reaction with contaminants present in the concrete. It means that durability is the ability of the concrete to withstand damaging effect due to environment under a long period of time. The durability of the concrete may be reduced due to some environmental effects. For example, it can be exposed to external effect or internal effect. Okay, so in durability, we have external cause, which is the physical, chemical, or mechanical attack. For example, weathering, extreme temperature, abrasion, and also electrolytic action. The common form of chemical attack is leaching out of cement and also some action of the sulfates. Okay, so that is for external cause. There is also internal cause that will reduce our durability of concrete, which is the alkali aggregation in concrete. This interaction will cause volume change due to differences in thermal properties of the aggregate and also the cement base and the permeability of the concrete. Okay, how do we improve our durability of the concrete? The recommended ways to have durable concrete are we use low water cement ratio and then we well compacted the concrete. We provide good workmanship so that we can reduce the porosity and use sufficient cover over reinforcement for reinforced concrete, and also we use aluminium sulfate resistant cement Portland blast furnace or Portland pozzolana cement to improve the durability of the concrete. Okay, so the third properties of hardened concrete, the permeability of the concrete. Concrete has a tendency to be porous due to the presence of void formed during or after placing. The void will cause the penetration of substance and will affect the durability of the concrete. So for example, the calcium hydroxide leach out. So, and also ingress of air and moisture from the environment will result in corrosion of reinforcement in the concrete. For a liquid retaining structure, so permeability is very important so that we get the water tightness of the structure. So recommended ways to produce concrete of low permeability is by full compaction and also proper curing of the concrete. So low permeability is important because we can increase the resistance to frost action and also the chemical attack, and we can protect the steel against corrosion. The permeability of the cement paste is actually varies with the age of the concrete or with progress of hydration. With age, the permeability will decrease because gel gradually fill the original water-filled space, so we reduce the void. For the same cement water-cement ratio, the permeability of paste for coarser cement particle is higher as compared to those with finer cement. So that is why we need to use finer cement to get better durability. In general, the higher the strength of the cement paste, the lower will the permeability. Okay, some factors influence the permeability of the concrete is, the first one is water-cement ratio, the curing process, the compaction, the workability of the fresh concrete, durability and also the porosity of the aggregate, the age, the grading of aggregate and also the type of structure that we are going to construct. Okay, so next is the shrinkage properties of the concrete. Shrinkage can be caused by the settlement of the solid and the loss of the free water from plastic concrete by the chemical combination of cement and water, and also by drying of concrete. So we have plastic shrinkage and also drying shrinkage. And the shrinkage is depending on the amount of drying that can be take place. It influenced by the humidity and temperature of the surrounding air. There are two types of shrinkage. We have plastic shrinkage, which is basically take place before concrete has set. So normally occur during the first few hours after fresh concrete is placed. During this period, moisture may evaporate faster from the concrete surface. Then it is replaced by bleed water from lower layer of the concrete mass. Okay, so plastic shrinkage or plastic cracking is cracking that occurs in the surface of the fresh concrete soon after it been placed, while it is in stiff plastic condition. So you can see some cracking on the surface of the concrete. Another one is drying shrinkage. When a hardened concrete cured in water, it's allowed to dry. It first loses water is drawn out of its cement gel. So after an initial high rate of drying shrinkage, concrete can continue to shrink for a long period of time, but at continuously decreased rate. Factor affecting shrinkage. So we have actually 5 factors. The first one is the aggregate. The aggregate acts to restrain the shrinkage of the cement paste, so the concrete with higher aggregate content exhibits smaller shrinkage. And also, for concrete with aggregate with higher modulus of elasticity or rougher surface is more resistant to shrinkage process. The second one is the water-cement ratio. Higher the water-cement ratio will lead to higher shrinkage. So as we decrease the water cement ratio, the paste strength and stiffness decrease, and as the water content increase, so we can shrinkage will be increased. Okay, the third one is the member size, the volume, the rate and the total magnitude of shrinkage decrease with an increase in the volume of the concrete member. However, the duration of shrinkage is longer for a larger member. The fourth factor is medium ambient condition, which relatively humidity greatly affect the shrinkage. The rate of shrinkage is lower at higher value of relative humidity. The shrinkage becomes stabilized at low temperature. And also the admixture that we add, effect of various form as admixture to admixture. So any material which is substantially change the pore structure of the paste will affect the shrinkage characteristic of the concrete. As the pore refinement is enhanced, then the shrinkage is increases. Okay, so next we are going to look into concreting in different environments. For example, we are going to do some construction in seawater. For structure in seawater, they may be damaged by the crystallization of salt inside the mass-in zone, where the concrete is subjected to alternate wetting and drying of the seawater. The durability is depending mainly on the density of the concrete. So the required density can be attained by using maximum water cement ratio from 0.5 to 0.45 to 0.5. So that and also we provide concrete with high compacted. For example, let's say you are going to build bridges in the seawater, then we need to take care of the durability of the concrete by increasing the density. Reinforced concrete is much more open to damage due to corrosion of the reinforcement. The corrosion will result in increase in volume of the reinforcement, thus concrete will crack. A dense concrete cover prevents seawater from penetrating into the concrete and thus will protect the steel inside the concrete against corrosion. Also, we use granulated blast furnace slag as a cement replacement material, can increase the chloride resistance of the concrete due to seawater. Okay, this is an example of concrete degraded or rusted. We can see here the reinforcement is exposed to the environments that lead to the corrosion of the reinforcement. Okay, basically that's all for the hardened concrete. Thank you very much.